Dear students, welcome to this video number 4 on simultaneous fault. In this video, we shall continue numericals on two-port network. In video number 3, we have solved some problems on Z transform. In this video, we shall have some numerical on Y parameters. So I will take the first example, example number 1. Find Y parameters. And I will take this circuit. Let the value of the resistor be R ohm, R ohm and R ohm. Now I will find the Y parameters for this circuit using analytical approach. So let V1 be the voltage with plus and negative polarity. Let I1 be the input current, I2 be the output current, and let V2 be the output voltage. Now I will write a KCL equation at this node. Say this node is X and this node as Y. Now let us write KCL at node X. So this current is entering, so it is plus I1. Now the current in this resistor, it is leaving, so we can write it as minus V1 minus V2 divided by R, and this current also as leaving, you can write it as minus V1 by R equal to 0. Now rearranging the terms, we will have I1 minus 2V1R plus V2R equal to 0. So we can have an equation I1 is equal to 2V1 by R minus V2 by R. So comparing it with our standard equation, comparing with standard equation in terms of Y parameters, there is I1 is equal to Y11 I1, sorry, Y11 V1 plus y12 v2. So comparing these two equations, I will write number comparing 1 and 2. So comparing equation 1 and 2, we can write y11 is equal to 2 by r and y22, y12 it is equal to minus 1 by r. Okay, now let us go for KCL equation at node y. So now we can see this current I2 is entering to this node. So current entering, we take it as positive. Now this current, okay, now we can take current leaving at this node in this direction. So we can write minus V2 minus V1 divided by R, and there is a current in this resistor leaving, we can take it as minus V2 by R equal to 0. Rearranging the terms, we can have I2 is equal to minus V1 by R plus 2V2 by R. Now comparing it with standard equation, comparing with standard equation. What is the standard equation? I2 is equal to y21 v1 plus y22 v2, and if you compare equations, I will write the number 3 and 4. By comparing equation 3 and 4, we get y21 is equal to minus 1 by r and y22 is equal to 2 by r. Okay, so this is how we can find y parameter for this circuit. Now I will tell you some of the very important point to be noted here. Suppose uh, we can remember this concept so that we can write the y parameters directly. I will take numerical example now. Suppose this is our network. Suppose this value is 1 ohm, this is 2 ohm, and this is 4 ohm. Now we can convert. So before finding y parameters, let us convert these ohmic values to mho values. So 1 ohm, this is impedance. So let us find admittance. Admittance is 1 by Z. So it is 1 by 1, which will be 1 mho. So I can write in bracket here 1 mho. Similarly, 2 ohm can be written as 0.5 mho and 4 ohm can be written as 0.25 mho. Okay, so in terms of moles, our circuit will become like this. So this is 0.5 mho. Here we have 1 mho, and here we have 0.25 mho. Now how we can write y11? How we can write y11? Y11 is equal to The total, this is our, you can say this is our port 1. So the total admittance connected to this node 1, so it is 1. So this admittance 1 ohm plus 0.5, so it will give you something like, this is 1.5 mho. What is Y12? Y12, suppose this is our port number 2, then the admittance between 1 and 2, it is 0.5 mho. So we can write 0.5 mho and we can put minus sign to this. Hello sir. ಹಾ ಇಲ್ಲಿ ವಿಡಿಯೋ ಮಾಡತ್ತೀನಿ ಬರ್ತೀನಿ ಒಂದು 5 ನಿಮಿಷ. Similarly, Y21 will be equal to the admittance between 2 and 1, it is again 0.5 mho and we can put minus sign over here. Y22, it is equal to total admittance connected at this port, so it is 0.5 plus 0.25, so it will be 0.75 mho. So this approach we can uh, we can use to find the Y parameters for this type of network. For this type of network, we can find Y parameters easily using this approach. Okay, now let us go to another problem. Now I'll take example number 2. Find Y parameters I will take now the example which is asked in the university question paper. Okay, all values they are given as R ohm. Now we have to find Y parameters for this circuit. Now what I will do, I can write a set of KVL or KCL equations and I can manipulate and find the Y parameters. Uh, but I will use a different approach over here. Now I will try to convert this circuit to this circuit which we can consider as a basic building block for Y parameters. Okay, suppose this is Y1 ohm. Now I'm talking about in terms of mho units. Suppose this resistor is Y1 mho, this is Y2 mho, this is Y3 mho, then I know that Y11 it is equal to Y1 plus Y2. This is what we have already learned in Y-bus formation by inspection method. Y12 it is equal to Y2 and negative sign. Y21 it is minus Y2 and Y22 it is equal to Y2 plus Y2 plus Y3. Now how I can convert this network to this network? So we can use a series of star delta conversion. So let us start converting. Now you can see these three resistor, this resistor and this resistor, they are in delta. So I will convert this. This is the resistor. So this is R ohm, this is also R ohm, and this is our R. So here this neutral point, whatever is there, it is this neutral point. Okay. So now I will convert it into delta. So it is like this. Okay. So you can name the terminals if you want, X, Y, Z. This is X, Y, and Z. Let these now let this be you can say RxZ. You can take this as RxY, and this is RYZ. Okay, now let us find what is RxY. What is RxY? Now, because these resistors are equal, there is one shortcut formula is there which you can remember. It is R delta, R delta is equal to 3 times R star. So we can remember this shortcut formula. Now I am finding Rxy. So Rxy, it is in delta, which is 3 times, R star. R star value is R. So Rxy will be 3R. Similarly, your Ryz will be also 3R, and Rzx or Xz, that will be also 3R. So how your circuit will modify now? So your circuit will modify to this form. So you will have a delta conversion here over here. So this will be there, and then you will have one more resistor over here. These values are 3R, 3R. This is also 3R, and there will be this resistor R and one more resistor R. Now this resistor and this resistor, they are in parallel, so we can combine into one resistor. So your circuit will reduce to the form 3R. Now you have where you can combine 3R and R resistor. So what is the value? 3R into R divided by 3R plus R. So it will be 3R square divided by 4R. So it will be 3 by 4 into R. So this value, it will be 3 by 4 into R, and there will be this resistor R. Now we can see here, now let us convert this, let us go for another star to delta conversion. Now this resistor and this resistor, they are connected in star. Let us convert into star, into delta. So I will show that this resistor is 3R. Then you have a neutral point over here. This resistor is 3 by 4R, and this resistor is R. Converting it into delta. Okay. Now I will call this as, say, some R1, R2, and R4. Now we'll find the first value R1. What is R1? R1 is equal to, so you have this R1, it is between this here. So this is R1. So what is R1? R1 is equal to, you have to multiply this, that is 3R into R, so it will be 3R square plus this R into this 3 by 4R, it will be 3 by 4R square plus 3 by 4R R into 3R, so it will be 9R square divided by 4. Divide by, whole divide by, now opposite to this R1, opposite to this R1, it is 3 by 4R, so you will have 3 by 4R in the denominator. So if you take this R square common, then we will have 3, so it will be 12 plus 3, so you can take plus 9, so it will be divided by 4, you have in the denominator 3 by 4 R. So it will be R square and 24. So in the numerator you will have 6 value, in the numerator you will have 6 value, because 12 plus 3 15, 15 plus 9 24, so 24 divided by 6, it will be, oh sorry, 4, it will be 6, so it will be 6R square, and then you will have into, you can write this as 4 by 3, 4 by 3 R. So R, you will get this, it will be 8R. So 3 2s are 8R. So you will have 8R value. R1 value will be 8R. Okay. Now similarly, let us find the value of R2. So the value of R2. So I will erase this part. Okay. Now I will find R2 value. R2 is equal to, the numerator it will remain same, that is 6R divided by, now opposite to R2, now opposite to R2, this resistor is, your R2 value, R2 resistor will come over here, and opposite to R2, this resistor is there R, so it will be R, so the value will be uh, that will be 6R square in the numerator, and denominator it is R, so it will be 6R. R3 value will be, numerator it will be same, R square divided by, in the denominator, now this resistor we are finding, and opposite to this R3 will be 3R, so it will be 3R, so it will be 2R. Now we have find out the 3 resistors. Now how your circuit will look like? Your circuit will look like, you have one resistor. I hope the value is, then you will have, one value over here. So this value is 3R. This is I think it is R2. R2, yeah, R2 value, it is 6R. Then you will have one resistor here, that is R1. R1 is 8R. Then you will have one resistor over here, and the value of this is R3. R3 is 2R. Now we can reduce this network to simpler form. Write it over here. Now these resistors 3R and 6R, they're in parallel, so we can combine them into one resistor. So we will have this resistor here and one more resistor here. So this is 8R, 2R, and if you combine this, so this value will be 3R. If you find a parallel combination into 6R, so it will be divided by 3R plus 6R. It will be 18R square, 18R square divided by 9R. So it will be 2R. So this value will be 2R. Now what we will do, we will convert this network to our admittance form. So we want Y1 ohm, Y1 move here, we want Y2 and all. So we can have this. So this value, it will be 1 by 2R. This value will be 1 by 8R, and this value will be 1 by 2R. So now what will be your Y11? Y11 will be 1 by 2R plus 1 by 8R. So we can take this 8R as LCM, then we will have 5. So it will be 5 by 8 divided by R. So that will be Y11. Y12 will be 1 by 8R, and it will be minus sign. Y21, it will be 1 by 8R, it will be minus sign, and Y22 will be again 5, 8R. So this is how we will get the Y parameter for this circuit. Now I have not written any equations, KVL and KCL equations. Simply I have used a series of star delta conversion, and we would able to find the Y parameters for this circuit. Okay, so this is valid. Okay, so up to this only in this video. We shall continue in the next. Thank you very much.